Hi student. Now next lecture number 13, topic organic chemistry, subtopic preparation, properties, bonding and application of alkyls and aryls of organotin compounds. Now tin is symbolized as Sn. Let's see introduction part. Organotin compounds are defined as those which contain at least one carbon-tin covalent bond, the carbon atom being part of a organic group. Organotin compounds, or which can also called as stannis, are chemical compounds based on a tin with hydrocarbon substituents. Organotin chemistry is part of wider field of organometallic chemistry. The first organotin compound was diethylene, diethyltin diiodide. This is the first organotin compound which is discovered by scientist Edwin Franklin. This is the introduction of organotin compounds. The reaction of Grignard reagent with tin halides. It is a reaction of Grignard reagent with tin halides. For example, tin tetrachloride, which is provided synthesis of tetraethylene tin. So, tetraethylene tin, which is organotin compounds, get prepared with the help of Grignard reagents. So, this is the introduction part. Organotin compounds having the formula R3SNX or R4SN are prepared. First one by the preparative property by reacting metallic zinc with organotin compounds having the formula RSNX3 or R2SNX2, where X stand for halides such as chlorine, bromine, iodine and alkyl carboxylate group. The symmetrical tetraorganotin compounds, especially tetraalkyl derivative, can be converted to various mixed chloride by redistribution reaction. So these are the reaction where redistribution takes place. The organotin hydrides are generated. This is the preparation part. The organotin hydrides are generated by reduction of the mixed alkyl chloride. For example, treatment of dibutyl tin chloride with lithium. Lithium aluminum hydride LiAlH4 gives the dibutyl tin dihydride, which is a colorless visible oil. So this is the reaction where organotin hydrides get generated. This is the dibutyl tin chloride allowed to react with LiAlH4 and there is a formation of dibutyl tin takes place, dihydride. Dibutyl tin dihydride takes place. The Woods-like coupling of alkyl sodium compound with tin halides yield or give the formation of tetraorganotin compounds. Now let's see the properties of organotin compounds. Organotin compounds which having oxidation state 4 are used globally as a stabilizer, catalyzers and biocidal agents. However, due to the increased focus in application of organotin compounds in healthcare, their use in industry and agriculture not remain so longer. Bioactivities of organotin includes the showing some biological activities such as anti-cancer, antiviral, antiparasitic, antimicrobial activities and anti-hyperbilirubinemia have been widely discussed here. Now, due to this, various biological activity they can having their use in pharmaceutical. Now let's see the bonding and structure in organotin compounds. Organotin compounds are chemicals with at least having a SN carbon bond. That is, tin carbon bond should be present in organotin compound. Most of the organotin compounds are of having oxidation state +4 type. There are two types of organotin compounds which having organotin is having +2 oxidation state and +4 oxidation state. But among these two, +4 oxidation organotin compounds are most stable. Organotin compounds having oxidation state second are having their structure mostly in a band form, pyramidal or distorted form. This is due to the presence of sterically active lone pair of electron which actually does not take part in bonding but occupy position which is directed away from the strongly bonded site. So due to this presence of lone pair, it having bent pyramidal or distorted structure. Organo tin compounds in which tin is in a oxidation state second. Tetravalent tin atoms are tetravalent, that is tin which is having plus for oxidation state is always tetrahedral in geometry. Now these are the structure where tin is present in the form of sp2 hybridized. Now this is the tin which is also present in a this is the example of polydimethyl siloxane. This type of where here is a silicon, instead of silicon there is a tin also can be present, and it also show this type of polymerization. So tin organotin compound also show this type of polymerization. It is not a tin, it is a silicon, but instead of silicon you can use as a tin and which show polymerization. Now let's see the application of organotin compounds. They are widely used as a polyvinyl chloride, that is PVC, stabilizers, biociders, anti-fouling paints. So these are having some application which but reduce environmental contamination. Non-biological application of organotin compound. Organotin compound used as a reagent and intermediate in some organic synthesis. Another important use of organotin compound is in the stabilization of PVC. Many organotin compounds are used as a homogeneous catalyst in industry. Several organostenosilanes have been shown extremely versatile, extremely used in act as a versatile catalyst for trans-esterification reactions. So some of the organotin compounds also used in case of a trans-esterification reactions. In case of biological application of organotin compounds have found a variety of application in agriculture as well as in medicine form. The first organotin compound to reach commercialized in agriculture is triphenyltin acetate. This is the first compound which reached in agriculture form, and triphenyltin hydroxide, both of which are widely used in agriculture. Organotin compounds are also used extensively as preservatives of wood, preservation for preservation of wood, and as agriculture fungicides and insecticides. So most of the organotin compounds used as a preservative of woods and fungicides and insecticides. And in medicine, they are used in cancer therapy and in the treatment of fungal infection. So organotin compounds are having their use in cancer and as a fungal infections. So thank you guys for watching this video. Thank you so much. For the more information, visit videos available on the internet. So thank you so much.